Okay, now we're going to kind of pick up where we left off in the factoring chapter, where we were doing perfect square trinomials and factoring those. Well, sometimes if you have those, fine, you can take the square root of each side, which we're going to be doing. But if you don't have a perfect square, we're going to talk about how we can make it a perfect square by doing a process called completing the square. And then we'll use those factoring methods. So here's the steps. You would isolate the b squared plus, the x squared plus bx. Remember, plus c equals 0 is the rest of it. So you just get this part by itself. You take half of the b term, you square it, and then you add it to the expression. Well, if you're adding it, if it's an equation, you do have to add it to both sides. Right here, we're just going to complete the square by saying what c needs to be. So we take half of the b term, which would be 3, and square it. We're going to add 9 to each side. So 6x plus 9. The reason we're doing this now is because we're going to use that. That would factor into this perfect square trinomial, which we know then what to do and how to solve when we get something like that. So again, if I want to find what I need to add to this expression, my b term is negative 12. Half of negative 12 is negative 6. Square it, I get positive 36. So I'm going to add positive 36 to each side. And how is this going to factor? A minus and a square. Then we could use that in solving. So, and if it's not like this, if it's not a perfect square to start with, we will be completing the square. So we have to look first to see if it is a perfect square. So looking at the left side, is x squared minus 10x plus 25 a perfect square? Well, it looks like it could be, so let's test it. First one's a perfect square, last one is. Multiply those two together and double it. Do I get that? Yes. So it factors into the quantity x minus 5 squared. Now I'm going to do what I did before. Take the square root of each side. So this is kind of a review right here. I get x minus 5 equals plus or minus the square root of 7. And before I let you leave that, now we're actually going to do the work. And so when it says round to the nearest tenth, when I take my square root, I'm going to round to the nearest tenth. So here I would need to add 5 to each side. I'm going to actually at the same time. So I get x equals 5 plus or minus, and now I'm going to take the square root of 7, which is 2.6 rounded to the nearest tenth. So here we actually will get answers. So 5 plus 2.6 would be 7.6, and 5 minus 2.6 would be 2.4. So if you can complete this, if it is a square, just take the square root of each side, but go that extra step that we did not do before. Actually take the square root. On the left-hand side, is this a perfect square? Well, no, 3 is not a perfect square. So I'm going to subtract 3 from each side and get a squared minus 14a equals negative 13. So that would be the first step. Now I take and complete the square. I ask myself what's the square root of the b, which is negative 14, and square it, I get 49. So I must add 49 to both sides. And don't forget to do it to the right side. Okay, until it's an equal sign there. So I get a squared minus 14a plus 49 equals, and then when I add 49 to 13, I get positive 36. Now I do have a perfect square. Remember, that's why I did what was called completing the square here. So I get this. So now when I take the square root of each side, I get a minus 7 equals plus or minus, and 36 is a perfect square, 6. So I would now need to add 7 to each side to get a equals 7 plus or minus 6. And now I do the math. 7 plus 6 is 13. 7 minus 6 would be 1. So make sure you go ahead and simplify it. Alright, is the thing on the left side a perfect square? Well, 9 is a perfect square, but when you take the square root of it and double it, you don't get the negative 24. So we need to isolate, so I'm going to subtract 9 from each side and get x squared minus 24x equals negative 9. So then I go through the process, remember, of taking half of 24 and squaring it. That's going to give me 144 that I'm going to add to both sides. So I get x squared minus 24x plus 144 equals, I add over here, I am going to get 125, I think, right? Subtract 9, so that would be 5, borrow from that, yes. 125. I'm going to read that 5, see if I can make it a little better. That kind of made it worse, so let me erase that and write a little neater for you. 135, that's supposed to be. I knew there was something wrong with that. Couldn't figure out, the math didn't seem to work right. All right, 135, sorry. So factor this into x minus 12, quantity squared, equals 135. Take the square root of each side, so I get x minus 12 equals plus or minus the square root of 135. So I'm going to add 12 to each side. I get x equals 12 plus or minus. Then rounding the square root of 135, I get 11.6. So 12 plus 11.6 is going to give me 23.6. And 12 minus 11.6 is going to give me 0.4. All right. Now, so far, this has worked because with the x squared term, it's at a coefficient of 1. So if it does not have a coefficient of 1, we are going to have to get it to be a coefficient of 1. So how would we do that? We would divide everything by 5. At the same time, I think I'm going to isolate the x squared and x term, so I'm going to add 7. So I'm going to divide by 5. And then when I write it, again, I'm going to have that over here. So this gives me x squared plus 2x equal 7/5. I kind of did a couple of things there at once. Okay, so now to complete the square, half of 2 is 1, 1 squared is 1. So I'm going to add 1 to each side. So I get x squared plus 2x plus 1 equal. I'm going to think of that 1 as 5 over 5 since it's already an improper fraction and just leave it 12/5. Again, there's other ways you can do it, but that's the way I like to do it. So now this is a perfect square, so I'm going to factor it into x plus 1 squared equals 12/5. So I'm going to take the square root of each side, and I get x plus 1 equals plus or minus the square root of 12/5. So to do this on your calculator, you probably ought to take 12 divided by 5 first, and then hit the square root. You could do the square root of 12 divided by the square root of 5. I don't really care how you do it, but we would end up with, we're going to have to subtract 1 from each side, so we get negative 1 plus or minus, I gotta see what my calculations give me here, 1.5 when we round it off. So x equal negative 1 minus 1.5 would be negative 2.5, and negative 1 plus 1.5 would just be 0.5. So those should be your two answers.